Assalamualaikum and a very good morning to Sir Tuan Yusof. My name is Zulfakri and I'm going to present my lab report entitled Hydrostatic Pressure Experiment. Hydrostatic pressure is a force exerted by a fluid to an area at rest because of its weight against the surface area, and the center of pressure is a point on the immersed surface at which the resultant hydrostatic pressure force acts. The objective of this experiment is, first, to determine the hydrostatic force due to water acting on a partially or fully submerged surface. Second, to compare the experimental hydrostatic force to the theoretical hydrostatic force. And lastly, to understand the hydrostatic pressure distribution. In this experiment, the hydrostatic force and center of pressure acting on a vertical surface will be determined by increasing the water depth in the apparatus water tank and by reaching an equilibrium condition between the moments acting on the balance arm of the test apparatus. The apparatus and material for this experiment: first is hydrostatic pressure apparatus, second is water, and third is set of weight. We perform the experiment by taking the following steps, which is the first step is to wipe the quadrant with a wet rag to remove the surface tension and prevent air bubbles from forming. And second step is to place the apparatus on a level surface and adjust the screw-in feet until the built-in circular spirit lever indicates that the base is horizontal. And next step is we have to position the balance arm on the knife edge and check that the arm swings freely. Next, we place the weight hanger on the end of the balance arm and level the arm using the counterweight so that the balance arm is horizontal. After that, we add 50 grams of weight on the weight hanger and we add water to the tank and allow time for the water to settle. We close the drain valve at the end of the tank and then slowly add water until the hydrostatic force on the end surface of the quadrant is balanced. This can be judged by aligning the base of the balance arm with the top or bottom of the central marking on the balance rest. And then we record the height of the water, which displays on the side of the quadrant in millimeter. If the quadrant is partially submerged, we record the reading in the partially submerged portion of the raw data table. And we repeat the steps by adding 50 grams of weights each time until the final weight is 500 grams is reached. When the quadrant is fully submerged, we record the readings in the fully submerged part of the raw data table. And we repeat the procedure in reverse by progressively removing the weights. And we release the water valve, remove the weights, and clean up any spilled water. The following dimensions are recorded, which is the height of the quadrant and face, the width of the submerged, the length of balance arm, and the distance from the base of quadrant to pivot. And all mass and water depth readings should be recorded in the raw data table, and this is the raw data table. The mass and the depth of the immersion depends on the value we got from the experiment, and both for the value of the partially submerged and the fully submerged must be recorded. We need to calculate the hydrostatic force based on the formula given and the theoretical depth of center of pressure below the pivot for both partially and fully submerged quadrants using the formula, and the experimental depth of center of pressure below the pivot, and all the value we got from the calculation must be written in this result table, which is we need to include the mass, the depth of immersion, the hydrostatic force, theoretical depth of center of pressure, and experimental depth of center of pressure. As for the discussion, the force applied in the system vertical force of biomaterial counteracts the mass added to the hanging arm. So we know that if we move away from the sea level, the pressure will change either with air or with water. So in our experiment, there's a change in pressure because of the weight of the water above, and buoyant force clearly shows the properties of the water. The water pressure was so high that we add the mass of 50 gram to 500 gram, even still quadrant was able to support it in static equilibrium. The relationship between the hydrostatic force and average depth for the partially submerged and the graph of hydrostatic force and average depth for fully submerged is also linear. Our theoretical force compared to the measured force were nearly identical with a small percentage errors. The graph of hydrostatic force and average depth for partially submerged is not perfectly linear. That's all from me. Thank you.